Hello everyone, this is Bashir with you. Today we will be talking and explaining the solution of the problem, container with most water. So the statement of the problem mentions that given n non-negative integers, a of 1, 2, a of n, where each represents a point at coordinates I, a of I. And vertical lines are drawn such that the two endpoints of the line I is at a of I and I0. Find two lines which together with the x-axis forms a container, such that the container contains the most water. So let's see the example given below. So the array contains elements 1, 8, 6, 2, 5, 4, 8, 3, 7, and each one, as the statement says, is a vertical line represented by I, A, I. We will have two pointers, one pointing to the first element, and the second one is pointing to the last element. If we pour water into the current container, it will spill from the smallest edge, rim. And with this, we are forced to this constraint. So at each two vertical lines, we will choose the smallest one. In the case of two pointers, one pointing to 1 and the other one to 8, we will have the minimum height, which is 1. And the distance from 1 to 7 is 8. So the container will be 8. If we move the first index to the second index, now we will have 8 and 7. The minimum height is 7 and the distance is 7. So 7 multiplied by 7 is 49, which is the biggest container so far, comparing to 8. All those steps will be explained in the second section of this video, which is an animated explanation of the code. So let's go ahead and deep dive into the realm of the solution. By the way, if you didn't try solving the problem by yourself yet, I encourage you to try solve it yourself. Then, afterward, watch the solution. So the solution I proposed is O of n for time complexity and O of 1 for space complexity. So the function that will compute max area will have an array as an input and int as an output. So first, we'll create a variable for holding the maximum area of a container initiated to 0. We didn't compute any value yet. The second line is for the first index, the left index which will point to the first element of the array. The next assignment is for the right index that will point to the end of the array. The second portion of the code is the logic that will calculate the maximum container. So within the when condition, as long as the left index is smaller than the right index, the condition will be met. For the current values, we have the left index is pointing to 0 and the right index is pointing to 8. So the code will proceed to start the while block. The first thing that happens is the distance is calculated, which is the difference between the right and the left index. The current distance is 8 minus 0 equals 8. Next is the minimum height. As we said earlier, the fluid will adapt to the smallest extremity of the container. In our case, we compare 1 and 7, so we take 1. Next, we calculate the new area, which is calculated by multiplying the minimum height with the distance, 8 multiplied by 1. Next, we compare the calculated area and with the already saved maximum area. So 0 comparing to 8. 8 is the maximum. So next, after taking the maximum area, we will try to advance from the smallest element, which is 1 in our case. So we increment the left index since we need to find the largest possible height for our rectangle. We moved forward from the shortest bar. Next, the condition is still valid, so we calculate again the distance. Now the distance is 8 minus 1, 7, the minimum height is 7, and the new area is 49. So we compare the new calculated area and the previous one, 8 comparing to 49. So 49 is the new container that can contain the most water. So we go ahead and compare the height in order to advance from the smallest element. 7 comparing to 8, so we decrement the right index and we go again through the while loop as the condition is still met and valid. So we calculate the distance, which is 6, and the minimum height 3. The new area is 3 multiplied by 6, 18. So 49 is still the maximum after the comparison. We go ahead and advance from the smallest element, 3 comparing to 8, so we decrement the right index and we go through the while loop as the condition is still met. After that, we calculate the distance, which is 5, and the minimum height is 8. The new area is 8 multiplied by 5 equals 40. So 49 is still the maximum after the comparison. We advance either the right or the left index as they are equal. So we advance and decrement the right index, the condition is still met. The distance is 4, the minimum height is 4. The new area is 4 multiplied by 4, so it's 16. We compare 16 to 49 again. 49 is still the winner. So we go again until the win condition is no more met. And if we found any max in the road, we pick it and update the maximum area variable. So now, the condition is no longer valid, as the left and right index are now equal, so we return the max area, which is 49. So now we finish the explanation of the container with most water problem, and you get the chance to have a more visual approach of the chosen solution. If you have any problem that you would like to be explained, just post it in the comment section and I will be more than happy to tackle it. I will again play the animation as usual so you get the chance to follow. Enjoy and feel free to pause it at any time.